Okay. I mean, you could turn on like push to talk. I think that's nice. Well, I used Zoom the other day. I haven't explored Google Hangouts just yet. That's another option. Okay, so just some announcements. On Piazza, you should have seen your tests from the part one of chapter 8. If you take a look at that, the PDF is posted with all the people that I got. Names are blotted out. I hope you recognize your own handwriting so you can see how you did. And overall, their scores were, the average was over 100% because of all the extra credit. So good job. And then in the future, depending on whether or not school opens, there's going to be a part two. And for those people that didn't take part one, we'll just put it all together and see what happens from there. What's with all the rustling? Is that me? Ah, I see. So I can turn specific users down, I think. Right, I see. Well, it seems like most people muted themselves when they're not talking. So I think that's a good practice. Thanks, Caleb. Okay, if you do need to say something, unmute yourself, just chime in and interrupt me at any point. Uh, cool. Where was I? Right. So if you didn't take part one, when we get back to school, whenever that is, or even online at the rate we're going at, is you'll be given a part one and part two, and then you just take both of them at once, taking how much time you need. If you did do well on part one, let's say you got like 100%, then you can skip that portion of the test to make it fair for those and keep your original score. And then I just grade part two and I put it together. It's a lot of grading on my end, but you're going to get the highest grade possible as long as you put in the effort. Okay, any logistical questions related to chapter 8, that test, or anything before um, the extended break, like homework, how to turn things in? Any questions? I'm not sure where you should type. I think algebra 1. You can't type in a voice channel, can you? It's just talking. Okay, cool. So yeah, if you have text-based question, then type it into there, um, and then we'll use these two together. All right, because a couple people emailed me their homework. That's great. I'll update the gradebook. For the others that are still working on it, just send it in when you can. Because of our situation, it's not going to be late or anything, just to make it fair. And I think, like as on the teacher side for updates on SFUSD, there hasn't been anything spectacular just yet. We're still on our break, and we are still planned to go back to school, I think April 6th. My department chair and the principal are going to have like a meeting. I'll get more news probably Tuesday afternoon, and to you all maybe Wednesday. Soon after that, there should be an update on what our situation is. Because after this week, there may be some updates because we were scheduled, like teachers were scheduled to go into school next week, but that's not the case anymore since we have the shelter in place. So I'm unsure. What I do know is I'm still getting paid, so I still gotta do something for you all. Homeworks will be graded later tonight, and if you took part one and you felt like you did well, that should have been updated in Synergy. So go check that and look at your test. If there's any discrepancies, let me know. Okay. Any questions, logistics related? You can type them in or just ask me. No? Okay. If you do have, if like my mic or sound or something like pops up, just let me know verbally, and then I can go around and fix it. I hope this setup is okay. So if you click on, or if you see my screen, yes, do you see that? Is it large enough? I don't think I can zoom in anymore on Go Live. So, uh, so yesterday there was this junk that happened over here. It's rather confusing, and I think I need to reformat like my notes so that I give more spacing between these problems. The idea, I wonder if you see where I'm pointing. No, you don't see where I'm pointing, so that's annoying. Uh, I think there's a presenter view somewhere in Notability. This one. Yeah, so you see this little dot, right? That's my pen. I'm using my iPad. That's my tablet. So this thing is where I'm currently pointing. So I'm going to space all of this stuff out. We did some review. This thing over here is factored form for a quadratic, right over here. That's standard form. We solve for x by setting it equal to 0. And if you notice, that's what the work is over down here in green. Okay, so you should be comfortable with that if you're good with factoring. If not, then you need to do more practice either in your Orange Merrill textbook or look at this classwork and try these problems yourself, and then go on and look at your key, this exact sheet. With parabolas, the second part of chapter 8 has to deal with graphing parabolas, and that's what this problem over here kind of talks about. So we figured out that in this problem it looks like this. Then over here, for these four, we only did like one of them. We kind of estimated the x-intercepts because those are really useful for graphing. When I previewed the quadratic formula, if you already know that, that's great. It saves you a lot of time, but we'll get there in not chapter 8, but chapter 9. So it's upcoming. And all this stuff is rather important for Algebra 1. As I said, I think for mainly Block 7, but not Block 8, if you're uncomfortable with working with quadratics, if you're factoring or using the quadratic formula, then I'm hesitant to pass you on to geometry and then later on to Algebra 2. This stuff you really got to know well in order for me to be comfortable passing you on to the next step of math. So spend in the time, even though we're not in person, to really understand what's going on. I reply to emails rather quickly because I got nothing else to do. Within like 10, 15 minutes, you should get a response, okay? So the one new idea I want to test out in an attempt to teach is this part, okay? Notice this kind of equation right here. That thing is called graphing form in our textbook, but it's also called vertex form, and that is a new idea. And so if I work through like this page, we'll take a pause and then see what happens and adjust from there. So think about on your end, like pay attention to the math, but also pay attention to like how like have some suggestions for me on how I can do this teaching online better. Okay. All right. And I started recording this stuff. I'll see if I can edit it and then post it on the YouTube for those students that aren't able to join us today. So you can let your friends know if they weren't able to join. And later when school starts up, you have another resource to help you review. All right. So over here, we have this thing, right? Two equations that don't immediately look like a quadratic. It looks kind of funny. You have a square, you have a multiplier, you have this thing sticking out. What the heck's going on? These things actually turn out to look exactly like this, okay? And this is standard form for a quadratic, okay? A, B, and C here, A, B, and C are all numbers, whole numbers, like negative or positive, and if it's 0, then it doesn't exist. And now let's check. So for this problem, right? In part A, it says, remember order of operations. How could you verify that they actually are quadratics? Yes, we can. We'll do so on the side. How do I fit this? Maybe over here. Okay, so in our first step in this problem, if we're following order of operations, let's take care of this part. Oops. Let's take care of this part first. Oh gosh. Why isn't that working? Okay, one more time. Ooh. Okay, go back here, go back here. Okay, there we go. All right, so we're going to take care of this part right here. Okay, that's the exponent part. So we're going to square it out. Multiple ways to go about this. If you're more comfortable doing this box method, -2, x and -2, you can. You can also FOIL. X times x is x squared. -2x, -2x, and then positive 4x. And that's just this middle part. So if I were to write down my next step down here, I still got my 3. Oops, it's a funny looking 3. I'll write in brackets and combine like terms of this stuff, right? So it looks like x squared minus 4x plus 4, and then minus 5. Okay, that's step 1. And afterwards, we are going to distribute this here 3 to each one. Maybe this time I'll demonstrate FOIL, so they have to be multiplied out like so. We have y equals 3x squared negative 4 times 3 minus 12x plus 12, and then we still got a minus 5. We can see we could combine these like terms right there. So our final equation for this part is y equals 3x squared minus 12x. 12 minus 5 is 7. That's part 1. And we can see it does in fact look like standard form over here. Write that down. Standard form. Stanford? Standard. Standard form. Okay. Any feedback so far? Should I go and multiply this one out? You good? Speak up if you want to see it. No? Okay. So, following through that, we see that this thing right here is another way to represent it. All right, and then we verified it. Going on to part B, use a graph in a table on your graphing calculator. I don't have one. To find the vertex of each function. Compare the vertex to its equation. What do you notice? Okay. Now this part, if you're working in groups, I would let you take the time to explore it. But since I'm here and I just want to get this information out there, I'll go and review like vertex, right? There is a shortcut to get to a vertex. It's another formula. It looks like negative b over 2a, okay, in orange. This is the x-coordinate of your vertex, okay? And this over here, this b is the same as standard form b. This a is the same as this standard form a. Okay, and using this formula, it will save you more time. Otherwise, if we're following what the textbook currently taught you, we have to factor this. It does look factorable, 21, is it? Yeah, I don't think this one ends up being factorable. I'm like thinking through, and like, yeah, so we have to probably like estimate the x-intercept since it's not factorable. Getting the vertex is going to be a bit more work. So we can use this shortcut over here, okay? Negative b over 2a. And notice, it's just the x-coordinate of the vertex. We still got to solve for the y-coordinate of our vertex. Let me continue demonstrating this in orange. Okay? For this equation, b here is equal to negative 12. A here is equal to 3. So if I were to substitute that into this formula, oops. Okay, let's make it consistent. I had the negative over here, like that. Negative of a negative 12 all over 2 times 3. So that's positive 12 on the top, 6 on the bottom. We know now the x-coordinate is 2, okay? And then the other part is plugging it back into the equation. So there's your 3 times 2 squared minus 12 times 2 plus 7. Which equals 12 minus 24 plus, oops. Gosh, okay, stop. Okay, plus 7, negative 12 plus 7, that gets us negative 5. So the vertex is at 2, oh gosh, what did I do? Stop. Okay, is at 2 comma negative 5. Okay, and then at that point, it's a little messy. It's like, okay, compare the vertex here is the step I'm working on. Compare the vertex to its equation. What do you notice? Well, if we go back, okay, there's your 2. Oh, look, there's a 2. there's a -5, and hey, look, there's a -5. Ooh, you think there's a relationship? Yes, there is. That's the beauty of vertex form. So without graphing, can you predict the vertex for this equation over here? Let's see. Maybe I'll continue down onto the side, change colors. Purple. Okay, so for this equation, y equals 1/2 x plus 3 squared plus 2. Do you think that the vertex is -3, 2, +3, 2? Okay, which one do you think it is? I give you two choices as we're learning vertex form for the first time. -3, this one, maybe I'll give you one more, like that. Take a guess. Think to yourself. And this is like the harder part of vertex form, thinking about, okay, is it supposed to be positive or negative? Anyone want to say which one it is and tell us why? Okay, so I'll take your silence as you're unsure, maybe you're still thinking. So in this problem, okay, let's see. So there's my original equation, yes? And if I go back, I scroll up a little bit, okay, right here, notice my x-coordinate here was positive. So then over here, it's being subtracted, yes? Okay, so it's minus a +2, and +2 is your x-coordinate. So for this one, if I'm adding 3, that means that your x-coordinate of your vertex has to be -3. And then the intercept over here, it's -5. You can think about it here, subtracting as adding -5. So then that means for this one, your y-coordinate of your vertex is +2. So we can delete these other ones. We don't need these. Okay. This one is the vertex. Okay. Maybe I'll just give you the formula at this point before we go on and practice. So for this problem, okay, let's do y equals a x minus h squared plus k, where h comma k is your vertex. Okay, so that's another useful formula. This is called vertex form for quadratic. Our textbook, it's a little weird. It calls it graphing form. Okay, and so in this formula that I wrote, notice it's minus h. We have a bunch more letters now. Minus h here, it's subtracting. So if it's adding, your h is then negative. If it's subtracting, then your h, the x-coordinate of your vertex is positive. So if I were to make more connections, I can use this formula. That equals h. And then k, that's being added, it stays the same. If you looked at a previous homework, I also gave some notes on completing the square, and I think vertex form. Sometimes you'll see it like this. I'll write it off to the side. Okay, y minus k equals a times x minus h squared. Okay, some textbooks write it this way. When you move on to Algebra 2, I think this is the one that book presents. You should be able to see that this one and this one over here are exactly the same. Can you tell right now why they are the same? Like what happened to this blue one up here for vertex form and this purple one or pink one? Yes, no? Okay, so maybe you paused and you thought for yourself, you paused the video to think about the question. So all we did here was we took away k from both sides, okay? And then so k plus k minus k, it goes away, so then it leaves this on the left-hand side. And it still works the same. K and h are your vertex. Those are the coordinates. All right, we'll scroll down, do a little bit more practice. So then we have another function. So I'm reading y equals this thing. It's quadratic. Let's explore and how to sketch without making a table first, right? So we can rewrite the equation in standard form and use the zero product property to find the x-intercepts. Okay, all that means is we're going to factor it set it equal to 0. Let's review that. Let's pick a color. Let's do red. So just like before, here's our first equation. Y equals x plus 1 squared minus 16. I'll cheat a little bit. That's what the thing squared is. The constants, we can combine. That's these numbers. We get minus 14. We need two numbers that, wait, no, I messed up. That's a 1. Okay, so then let's go back like that. Okay, that's a 1. So then this is negative 15. Otherwise, we couldn't factor it. So from here, if you're using your box and your diamond to factor this thing, x squared 15, don't forget the negative, the product, negative 15x squared. You have two x's to work with. It's probably 5x and negative 3x. You check, yep, that's right. Fill that in. X and x probably go here. There's a negative 3. There's a positive 5. So we just factored the same equation in red, and that looks like, we read the side lengths, minus 3. Okay, and this one I'd like you to type in the chat, what are the solutions to your coordinates? What are the x-intercepts? Someone can also shout it out too. Okay, you thought zero product property, well, if this whole thing, 0 equals all that stuff, okay, x plus 5 gets you to 0. What does x have to be? Yep, thank you. Ma-chan. X has to equal 5, oops, or it has a second value, positive 3. Okay, these are its x-intercepts. And as I mentioned before, if I go back a little bit and click here, okay, so all three of these things are the same thing from like my Friday or Thursday notes, right? All these things are mean the same stuff. Solutions, roots, x-intercepts. What's happening? Oh, in general chat, I see. All right. Okay, so we got there. We got our x-intercepts, that's this part, and now we have to find the vertex, okay? And we can go about it two different ways. We can do a little sketch of our graph. It probably looks like, where's negative 5? Let's call that negative 5. 3 is a little closer over here, positive 3. So it looks like this. And it probably opens upwards. We know another part. This thing is our y-intercept, okay? Then right there, should probably be down a lot more. Let's call this negative 15, okay? So now we have our 3 points. We can sketch our parabola. Well, yeah, we could sketch our parabola. It looks something like this. In this case, it's kind of annoying because maybe you think that the y-intercept is the same as its vertex down here, right? But actually, it's a little different. And how do I know? Well, looking back at this form, this is the y-coordinate of your vertex, okay? That means that it's actually a little bit more down. And so from the water balloon task, I'll switch colors real quick. You know that the vertex, it's halfway in between here. Okay, so if you're from -5 up to 3, that's a total of 8 units. You're 4 away on both sides. If you're 4 away from -5, you're at -1. So that's your vertex, like that. I think the green turns out kind of nasty colored, but well, whatever. So, and then you see if we plug it into the formula, -b over 2a for this equation over here, with b equaling, oops, I'll just write it out, b equaling +2, and then a equaling 1, we see that, -2 over 2 does in fact get you -1, the x-coordinate. And then from graphing form, you can see that, right here, go back, -1, you can see that here is the y-coordinate of your vertex. So to answer this question, wait, sorry, I lost track. I think we're still on part A. So we made the sketch. We know that this coordinate right here is -1, -16. Oh, question? No? All right. So, and then you go back and it's like, oh, we could also see that from vertex form right over here. You see that, oh, it's +1. And if I was looking at these notes from before, -h, well, if I'm taking away something, I have to take away -1 in order to get it to +1. So that's another way to go about getting your vertex. Looking at vertex form is one way. Going halfway between your x-intercepts, given that it's factorable, that's the other. And then you have this little shortcut that can also confirm the x-coordinate of your vertex. Okay. So we did that by evaluating that. What's the vertex? Down here. Obtain this lesson page and reevaluate the steps. And then I already cut to the chase. You see that right here? This thing? That thing's called graphing form. Why is this name appropriate? Well, it lets you easily graph it. Once you have the vertex, you have a lot of information. And tomorrow's stuff will probably, or Monday? I have no idea. We'll go over word problems now that we have like this new equation to work with for quadratics. What are the advantages of the equations compared to the zero product property in part A? Solving for the vertex, it's easier if you have vertex form. That's why it exists. If you had a standard form equation, you probably have to do some converting. There's other reasons why you would prefer that, but later we'll see you most likely will use the quadratic formula when you know it. So there's a practice problem. Find the x-intercepts exactly and the vertex. You can pause and then we can go over this. Try to do this on your own if you have a little sheet of paper, and I'll stay quiet for a little while if you want to work through this too, and then I'll write out over here my work for doing this, and then I'll talk about it. So yeah, I'll take your word for it. If you are practicing alongside me, then that's great. If not, then that's cool too. I think I spaced this one problem out a bit more compared to my others, so I can actually write bigger. If you needed me to move the screen at all, like up or down, also let me know. Either in chat in Algebra 1 channel, text channel, or just speak up with your mic. Okay. Because I know, like, while I'm streaming all this is kind of hard to follow because I didn't space it out. I'll do this better next time. Okay, so there's your equation. Maybe I'll write it nice and big. Y equals +2 squared minus 3. From vertex form. Wait, I said I'd be quiet, so I'm not going to mumble to myself. All right, so maybe you took some time to solve it. Maybe you got stuck. It took me like a minute or so to think about, wait, what happens after this point if you can't factor it? And that's the part I skipped. Where is it? I have another page somewhere here. So it mentions some kind of resource page. I thought I had this pasted in, but it looks like I deleted that page. But it takes you through those processes. I'm not sure if the one I posted on Piazza had that page. I'll update it. Um, it should have the algebraic steps that I'm demonstrating here. When you have something in vertex form, it makes it really easy for you to solve for the x-intercepts by doing some algebra. The steps are from here, from here, okay? Using the definition of an x-intercept, you know that the y-coordinate must be 0. So that's there and there for my little sketch. And now we got to look for those exact values. They're not whole numbers. If it were, then this thing would be factorable. So once we use that definition of a x-intercept, we can add 3 to both sides. And then from there, take the square root of both sides to undo this squaring. We're left with the positive or negative square root of 3 equals x plus 2. From there, you subtract, oops, I guess I messed up right here. I need to subtract x from subtract 2 from both sides. Minus, minus, and minus. Okay, and there are your 2 answers. It's harder to explain why there are 2, like why do you have to do plus and minus? In our textbook, they use absolute value. You may have seen that represented another way, because in this case, it crosses the x-axis twice. That idea of this is the line of symmetry, there has to be 2 x-intercepts in this case. It's going to require a bit more time to explain, and maybe that's another lesson. Okay. Questions? Any comments on how this went? Any suggestions on how to improve? Maybe, yes, no? Yes, Gary? Okay, maybe no suggestions. How many of you are on mobile for Discord? Did that end up being okay? Could you see enough of my screen? Was it large enough? Could you still see like people chatting? Because I haven't used Discord on mobile and I'm curious what it looks like on the student end. No? Okay, and those students that are on like laptops or desktops, whatever computer you have, that was okay? Oh, yes. Anybody? No? Okay. All right. Well, that concludes my math lesson of sorts of me just testing out stuff. If you want to talk amongst yourselves or if you have other non-related questions for me,